The image NASA didn't want to receive from the Deep Impact Probe. What they didn't want to see is a flash of light that kept them from seeing the crater that the impactor made. And the reason why there was a flash of light that blinded the camera was because they didn't have the right perspective of what made up the Temple 1 comet. Basically, NASA is now admitting about their failures in each one of these missions and trying to put a happy face on it while they're doing so. They're talking about how they sent the impactor to the Temple 1 comet to smash into it, and they wanted to do it in a way that they would be able to see the impact and see the crater that was made on what they thought was a solid comet.
And on the 4th of July, 2005, just 1 second out from the anticipated arrival time, the impactor hit. And what a magnificent spectacle it produced. Scientists were thrilled that they had struck so accurately. This produced the bright flash you see here, the energy of which is roughly equivalent to 5 tons of TNT. This flash was much brighter than scientists expected.
Much brighter, because they thought it was solid. And what the impactor did is threw up billions of pieces of fine dust, dirt, rocks that reflected the sunlight so much that it blinded their cameras from being able to see the impact.
However, ironically, the success of the first part of the mission caused an unexpected negative side effect. A large dust cloud was kicked up by the impact, which obscured the flyby's view of the impact crater. Dust outgassed from the comet for the next 13 days, peaking 5 days in, which made it hard to see the results of this interstellar bullseye. Although it did offer some interesting insights into the internal pressures going on inside the comet. Around 5 million kilograms of water and between 10 and 25 million kilograms of dust were ejected from Temple 1 in that time.
Which they did not expect. And we got to keep in mind, this was 2005, $240 million mission that, had it not been for the space probe Stardust having enough fuel, would have been a complete waste of money and therefore a NASA blunder.
Fortunately, scientists were able to rely on other eyes, at least to capture images of.
And those other eyes are the Stardust mission.
Back to the late 1990s, when cometary science was even more patchy. Although by this point we had sent 6 probes up to visit these enigmatic celestial bodies, not very much was known about their origins. It was believed at the time that comets were foreign visitors to our solar system, older than the Sun, having been formed from the loose pre-solar grains of dust that orbit other stars, before drifting through space towards us, only to be caught up in the Sun's gravitational pull. It was believed that this theory could be confirmed by traveling to one of these comets and picking up some of this loose dust, or stardust, that surrounds them in space. By examining the isotopic composition, scientists would be able to tell if it was unusual when compared to the dust given off by our own star.
Visual surprises. So when the Stardust space probe got to the Wild-2 comet, they were shocked and surprised. This is a $200 million project. And so then we'll see what they say about that.
But on the 2nd of January 2004, it finally arrived at its target, Comet Wild-2. And what it found was immediately extraordinary. Scientists had not expected much from Wild-2. Some NASA scientists described their expectation of it to be a rather bland object looking somewhat like a black potato. However, this is not what they found.
And what they're saying is, it looks to us like they might be craters, but they're not impact craters like they would expect for something that was solid. It's a kind of impact crater you would expect for a very loosely held together rock pile that leaves a, crater impact kind of looks that are nothing like what you would hit solid. That's what they're missing here, is because they weren't expecting it to be a loosely held together rock pile.
Instead, the surface of Wild-2 was covered with spiky pinnacles hundreds of meters tall, cliffs, massive holes jetting dust and gas out into space, even on parts of the comet that were pointed away from the Sun, and thus were expected to be less reactive. In short, the surface of the comet was unexpectedly alive and self-renewing. Something else was just as notable for its absence: craters. Unlike almost every other body in our solar system with surfaces exposed to space, there were no craters on the surface of Wild 2. This puts it in stark contrast to places like Mars or our own moon. Given the period of time Wild 2 is thought to have existed, it surely must have encountered other objects which impacted with it. So where had these craters gone? It shows that the comet's surface can either be self-renewing or active,
which is only because it reforms itself after impact because it is just a rock pile. They learned from Temple 1 too. They impacted it and didn't leave a crater, even though they're going to try and say otherwise, as we'll see. Dr. Brown wrote this to ask Dr. Brownlee why crystalline minerals, as opposed to amorphous, meaning no water, crystals form in water, as compared to minerals that form without water, which doesn't give the crystalline shape, should be found in comets. As I recall, you told me that Brownlee's response was that he didn't believe the data. See, data was already coming in that there's crystalline material being found in comets and asteroids, and he goes, I don't believe it because it's too impossible. And if crystalline materials are brought back by stardust, which they were, a good question to ask Brownlee is, how did crystalline material form in outer space? How do you get water, liquid water, to cause crystals to form in outer space? According to all theories for the origin of comets, except for the hydroplate theory, the water in comets should never have been liquid because outer space is too cold, especially where comets are thought to have been formed. And that's true, yet they have found crystalline and other minerals, clays, and other things that can only form in the presence of water, in the presence of liquid water in some cases, completely supporting the premise that they were jettisoned from the earth in the flood of Noah. And now, what did they actually find? Exactly what Walt Brown
and taking the samples back to the lab, scientists learned another completely unexpected fact about Comet Wild 2. It was not a visitor to our solar system at all. Unlike what had previously been believed, Comet Wild 2 had not originated from another star. It had been born from our own. By comparing the isotopic composition of the particles stardust collected with the samples from our own solar system, it was proven that Comet Wild 2 originated from the solar system.
Now think about this. It originated from the solar system. That's what they concluded. This didn't come from someplace else. It's too much like Earth. It's too much like our solar system.
And contrary to what all the ice on its surface might lead you to believe, the rock at its center was formed under white-hot conditions.
And the only explanation they're going to give for that is that somehow, that item had gotten really close to a solar nebula to get to thousands of degrees, which are chondrules. They're finding chondrules and other things that you have to get between 2,600 and 3,300 degrees. Yet, if that material was jettisoned from the pillars and the places where the crust was landing on the mantle, and it would have turned it to thousands of degrees very easily and then jettisoned it up into space.
Chondrules and calcium aluminium inclusions were both found among the samples stardust collected. These are structures that only form under incredibly hot conditions and can be found in other asteroids between Mars and Jupiter. So scientists had to rethink their theory that comets formed in cold conditions at the edge of solar systems, even if they do spend some time there. Both fire and ice go into making comets. And thanks to the careful, delicate way that the particles had been collected, scientists were able to find out one last surprising thing: the amino acid glycine. Amino acids are the building blocks that make up proteins that are vital for all living things. Although this does not mean that there was anything alive on Comet Wild 2, this does lend weight to the idea that it was from comets such as this, crashing into our Earth millions of years ago, that life's first building blocks found their way to our planet, which I'm sure you all agree offers a tantalizing glimpse into our own origins.
That's a horrible deception that is a result of not being out there with a voice, as all Christian creationists, flood scientists, people with Dr. Brown's 100% consistent with the hydroplate theory, 100% consistent with science, predicting all these things that they found. If we would have had that in the classrooms of colleges and universities, this would be foolishness to everybody. Why are you saying we were seeded by stuff it formed the building blocks of life in the absolute zero temperatures, near absolute zero temperatures, and total vacuum of space, when they can't figure out how to do these things on Earth. And so then, because Stardust brought this material back, and the Stardust space probe that dropped the collection container back on Earth, it still had enough fuel to go back to Temple 1 to go see if it could see the crater that the copper impactor made. Okay, now what they're going to say, the circle right here, that's where they know the Temple 1 copper impactor hit. That's what they know was the location that it hit. When Stardust flew by, this is the area where the impactor hit. Now, you and I can look at that picture and say, we don't see any crater here. There's nothing there because it hit into a floating rock pile. It didn't create a crater, but they're going to say it created a crater.
The crater that had been left by Deep Impact's payload. The mission was a success. From the images Stardust took, scientists were able to calculate that it was approximately 150 meters across, so 50% larger than they were predicting. From this, they learned that the surface of Temple 1 was a very fluffy material, made from more dust than was expected, and finer in substance than a powdered snowbank. The surface was incredibly porous. In fact, they were able to estimate that 75% of the comet was actually empty space.
Now, think about that. I mean, it so loosely came together, which when you think about anything coming together in space, it without an atmosphere, it's just like impossible for a bunch of rock to decide to get together in space. But yet that's what happened. And yet it's so loosely packed, perfectly explained by the hydroplate theory, that like 75% of that was empty space.
The whole thing held loosely together by gravitational forces. From analysis of the plume that had been ejected from Temple 1 after the impact, scientists were able to identify several interesting material components, including clays, silicates, sodium, and even organic material. While not life itself, these heavily rich carbon materials may have been carried to Earth by comets in the past, providing the vital materials that make up life here. Not only that, they were able to see other changes that had taken place on Temple 1's surface. 3 pits that had formerly existed had merged to become one. A cliff face had eroded back around 20 to 30 meters. This indicated that Temple 1's surface was a dynamically changing place, leading to interesting questions about how these formations had formed in the first place that scientists can now puzzle over
From now until they die centuries into the future, unless they embrace the hydroplate theory. That there was at one point, all the material of this asteroid was ejected with the same velocity, the same trajectory into space with the water environment around it, water molecule environment around it that allowed it all to come together. And it is so loosely held together, it changes its look just by the changing gravitational attraction basically as a building starts to collapse down because of the very loose forces. Your mission was a blunder. This is what this article says, which is not to say that the impact crater was obvious. I was hoping for a splashy feature around an obvious circular hole, but there was no visible splash. It was more subdued than the science team expected it to be. It took some really detailed comparisons of the old and the new pictures from Deep Impact and Stardust to confirm that there really were changes to the surface. After some judicious image processing and seeing things that aren't there, I'm going to add, you can make out an irregular shaped rim about 100 feet or 50 meters across and a mound in the middle. What that crater tells us, co-investigator Peter Schultz said, is that the surface of the comet where we hit it is weak and fragile. It's fluffy. Exactly what HPT would predict, not what any other theory can explain.
Comets are truly fascinating things. And it was thanks to the incredible work of the Stardust probe and the Deep Impact mission that we were able to learn a great deal about their inner composition and workings. While still retaining their beauty, we have pierced through their layers of enigma. We understand that they are not some foreign visitors, but originate here, from our own solar system, and may have even led to the blossoming of life itself on this planet. And it was human ingenuity and precision that allowed these discoveries to be made. So,
Glory be to man is what he's saying, and yet they're completely ignoring the god elephant in the room.
the next time you see a comet, with its beautiful tail flaring out across space away from it, it will no longer be quite so mysterious or foreboding. They may even be the reason you are here today. And all it took to learn this was to catch the dust from one and to punch another really, really hard.
If you have the wrong perspective of the past, you will have a wrong perception of the present and a wrong focus on the future. And this is what's caused the blunders. All these were conceived with the wrong idea of what they were going to get to.